G'day everyone. Today we are talking about section 6.8, factor by grouping. Our learning targets for today: I can factor a quadratic by grouping. I can factor any quadratic that is, quote, factorable. So factoring by grouping is something we already did when we talked about factoring when a is not 1. We used the grouping method in diamond split. And so really this is a bit of a review of things that we've already done. So when you have 4 terms, just like we did with diamond split, you are going to group the first 2 terms together and factor out the GCF. So if I look at just x cubed plus 2x squared, we're going to factor out x squared, and you're left with x plus 2. We're looking at this second group, the one I have double underlined, this 8x plus 16. Our GCF is positive 8. So we're going to factor out positive 8, and so we're left with x plus 2. Again, just like before, we want these two to match. That is good when they do. They need to match. That is one factor. These outside pieces go together to form our other factor. So our final answer is x squared plus 8 times x plus 2. Not everything's always going to have numbers. In this case, we have multiple variables and stuff. It is still the same procedure. We are going to group the first 2 and last 2 terms together and factor out the GCF. So if we look at the first group, r squared plus 4r, they both have r, so we'll factor out r, and you're left with r plus 4. Of the second group, all that's common to both of them is the letter s, so we are going to factor out the letter s. Again, we notice that our parentheses are matching. We want that. That means we have factored correctly. And then our other parenthesis is going to be those outside pieces, the r and the plus s. So our final answer is r plus s times r plus 4. Looking at the next one. One of the issues we have is that problems need to be written in standard form. And so you may want to make yourself a note of this, that they need to be in standard form. Since this one is not in the standard form, we are going to rewrite it in standard form. So we'll put our x cubed term first, and then 2x squared minus 5x minus 10. Once it is in standard form, you are going to group the first 2, last 2, and factor out the GCF. So I would like you to pause the video and do the factoring by grouping for each of the next 3 problems. All right, so we did that. We grouped the first 2, last 2 terms of each of these, and we have x squared minus 5 times x plus 2 for the first one, x squared minus 4 times x plus 3 for the second one, and 4x squared minus 1 times 3x minus 1. Now, one of the things you'll notice about these directions, it says factor completely. So we always have to check, does it factor further? And what we're looking for is when we have a power other than 1 on our variables. So whenever we have a squared term or a cubed term, for us it's going to be a squared term. Does it factor further? Is there more factoring we can do? So we're looking for, is it a difference of squares? So when I look at the first one here, we've got x squared minus 5. Is it subtracting? Yes. Is 5 a perfect square? No. Since one of my answers is no, that means that problem does not factor further. In other words, we're done. When I look at the middle problem here in green, I look and go, okay, we have a power of 2. We have x squared minus 4. Is it a difference? Is it subtracting? Yes. Is it a perfect square? Yes, 4 is a perfect square, which means we have a difference of squares. So like we talked about in 6-7, we have to factor further. So what do we square to get x squared? What do we square to get 4? And then we've got to do that a plus b, a minus b pattern. And then this x minus 3 that's on the end here that we didn't touch, that comes down. And then this is our final answer. That is factored completely. And so we go ahead and check our last one. Is it subtracting? Yes. Are they perfect squares? 1 is a perfect square, 4 is a perfect square, so yes, this one factors further. And so I'll start on the right here. 1 squared is 1. What do I square to get 4x squared? Well, what do I square to get 4? What do I square to get x squared? And so I get 2x. So it becomes 2x plus 1 times 2x minus 1. And again, we're going to bring down that 3x minus 1 to be part of our final answer. Again, I'm looking for a difference of squares. If it is not subtracting, I don't do anything. If both the numbers are not if both the terms are not perfect squares, I don't do anything. So you have to analyze your problem and decide, does this one factor further or not? All right. Now that we've completed factoring, we're going to make a little factoring guideline here. This is when I'm looking at a problem, the process that I go through for deciding how do I factor, what do I do, and whatnot. So the first thing I always do is look for a common factor. We called this the GCF. We did this back in section 6.3 was the first time we did it. And then we've always said, is there a GCF? Is there a GCF? Is there a GCF? That's the first thing you always look for. Once you've done the GCF, you need to look at the number of terms, because the number of terms will tell you which method to do. In this section, we talked about 4 terms. So we're going to group and so we group the first 2 and the last 2. And so that was the single underline, double underline stuff. That's when there are 4 terms. If we think about going back to section 6.7 is where we had 2 terms. So we're looking for a squared minus b squared, and that factors to be a plus b, a minus b, that difference of squares pattern. And again, that's only if there are 2 terms. If it's adding or the terms are not perfect squares, then that does not factor further. I might just factor out the GCF. There are 2 terms that don't factor. That means I'm done. So again, you have to kind of look at every single problem separately and see. All right, 3 terms. Anytime there are 3 terms, we're using a diamond. And it depends. If A is 1, it's diamond done. Well, let's put our little diamond pattern up here as review. So AC on top, B goes on bottom. So we had 2 options. We had if A equals 1, it's diamond done. That was section 6.4.6.5. If it's not, we got to use diamond split. And the phrase you hear me say, and you're going to hear me say it some more, if in doubt, split it out. If you're not sure if it's diamond done or diamond split is the full method. Where diamond done is a shortcut, diamond split will always work. If it's a trinomial, diamond split will always get you there. Even if it's a quote diamond done problem, diamond split will still give you the right answer if you follow the diamond split process. The last thing we always have to do is check to make sure it is factored completely. This is especially important with grouping. Like we saw in the examples in today's video, you could have x squared minus 4 or 4x squared minus 1 or x squared minus 9 or something like that. Always need to double check that it's factored completely. And again, we talked about that lazy friend. Bring down the GCF. If you factored out a GCF in number 1, you have to bring it down at the very end. That is step number 4, your last thing you always do. All right, so the rest of this slide is a bunch of review problems. So I would like you to pause the video, and try to do all of these or as much of these as you can. Feel free to look back at your notes if you need to, but take a couple minutes and try to factor all of these problems. All right, so on the first one here, just a straight diamond done from section 5.4, x minus 4, x minus 9. The y problem from section 5 with the negative c on top. Again, just a diamond done. As we keep moving on, 6, 7 saw when you have the matching numbers on the side, so x minus 6 quantity squared, or you could write it x minus 6, x minus 6. In section 6, we talked about factoring out a negative. Again, if the leading coefficient is negative, you have to factor out -1 first. So we did that, and then it became a diamond done. When we look, we'll just keep moving down here on the D problem. This is diamond split. Again, we factored out the GCF of 2 first, and then we did the diamond split with what's on the inside. Again, doing the rainbow. I see the 4 didn't fully show up here. There we go, 45 on top because of 5 times 9, 18, -18 on bottom. We did the whole diamond split process. If we shift over to the purple problem here, the F and G one, we factored out -1 because the leading coefficient is negative. 4f squared minus 49g squared, there are two terms. F is squared, g is squared, 4 is a square, 49 is a square, it is a difference of squares. So we wrote it as a squared minus b squared, or this squared minus that squared. Factored out using the this plus that, this minus that pattern, brought down our GCF of -1. Our last one here, we did grouping, grouped the first two terms, factored out the GCF of n squared, and then left with 5n minus 4. Grouped the second group, factored out 5. Again, we do not factor further because 5 is not a perfect square, so n squared minus 5 does not factor further. If you have any questions, make sure you come to class ready to ask. Otherwise, have a great day, everyone.